Good morning, children. This is my 9th class on chemical reaction and equation. We have covered almost all the portions. Now we are left with only two activities, that is corrosion and rancid formation. Let me discuss with the corrosion. Corrosion is the most important topic in the chemistry. What is corrosion? One question might be in your brain. State where one answer. It is an electrochemical process in which metal is getting converted into the metallic oxide in presence of moisture and oxygen. For any corrosion, we need corrosion to proceed. We need oxygen and moisture. Either of these two, any one is missing, corrosion will not take place. Alone in presence of moisture, corrosion will not take place. In presence of oxygen, also corrosion will not take place. Because it is an electrochemical process in which electric current charge need to flow. For charge need to flow, the moisture facilitates the medium of movement of charge. So, let's start corrosion. Corrosion is, once again I repeat the definition, corrosion is an electrochemical process in which metal gets converted into metallic oxide in presence of moisture and oxygen. Corrosion are generally reddish brown color in the case of iron. You can see, I will show you the example. This is an iron piece. It is rusted. It is a reddish brown color. The reddish brown color is the corrosion product of iron. Corrosion product of iron is known as rust. Similarly, in the case of copper, copper undergoes corrosion and it will have the greenish product. Corrosion product, copper oxidizes and gives copper oxide, which is green in color. So, the copper greenish color. In the case of aluminum, it has a white color corrosion product. See, for example, I will show you one activity here. What will happen? See, I took the iron nail inverter. Iron nail inverter in a test tube. In another test tube, I kept the anhydrous calcium chloride and the nail. In third test tube, I kept water, and over the water, there is oil. Now you might be wondering in which case corrosion will be faster. In all these three cases, which will have more faster rate of corrosion? Obvious, in this middle test tube, where there is a calcium chloride, anhydrous calcium chloride, it will absorb the moisture. So only it will have oxygen. Therefore, it will not corrode. Only it will have oxygen. Moisture will be absorbed by the anhydrous calcium chloride. So, what happens? It is moisture free, only oxygen, no corrosion will take place. Now we are left with two. Here also, water is there, and above the water I have put up oil. So oil does not allow the oxygen to get into it. Therefore, the water will starve for the oxygen. Water will starve for the oxygen. The amount of oxygen present in the water, it may initially corrode, but later on corrosion will stop. Because the oxygen present in this water will be used up by the nail for corrosion. And oil layer does not allow the atmospheric oxygen to enter. Therefore, nail will be safeguarded. The third case, here water is there and nail is there. Nail has corroded. You can see that nail has corroded because here water is there, moisture, and oxygen is also free supply of oxygen. Therefore, corrosion will be there. See, only this tube will have corrosion, other two will not have. Now, what actually happens? That we write the chemical reactions on this. Children, see, it is your iron upon reaction with oxygen, it gives Fe2O3, ferric oxide. Fe2O3, you are getting iron upon oxidation. This iron oxide, Fe2O3 plus H2, you can say in presence of moisture, what difference? Fe2O3 dot XH2O. Fe2O3, XH2O simply you can write it, XH2O. It is called rust. So metal is getting converted into metallic oxide. In presence of moisture, the rust formation takes place. This is called rusting of iron. Corrosion, due to the corrosion, there are huge losses to the industries, bridges, all the material which are made out of mainly of the iron and other metals too. Corrosion has got the millions of rupees damages, and the different organization of the nation, different industries uses the different methods for the protection from the corrosion. Now, how can we go for protection from the corrosion? How can we go for a prevention from the corrosion? The preventive methods of corrosion. What is the basic thing behind the prevention? Corrosion damages millions of properties. Rusting can weaken the bridges, flyovers, and the life is shortened. But what actually happens? What can we do for that? Either of the two, water or air, either of the two, any supply, if we cut off, the corrosion will stop. For this, what are the preventive methods you are using the corrosion? Any component, what we have, we need to go for prevention. What we do? Initially, we apply the oil, layer of oil, cut off the supply of oxygen. Another case, we apply the paint. What is the paint? A thin layer of synthetic coat. So, thin layer of synthetic coat, again it supply the cut-off of oxygen and save the component from the corrosion. Thin layer, it is like our cloth, a plastic cloth. A thin layer of coating on the metal, it does not allow the oxygen to enter into it, come into contact with the metal. Therefore, oxidation is stopped. Another methods are there that are galvanizing process, electroplating process, and cathodic production methods. There are the different methods. In a galvanizing process, metal is dipped into the molten zinc, and when it is taken out, a thin layer of zinc remains stuck with it. At that process, we say that it is a galvanization. What happens in the galvanization? The thin layer of zinc is covering the complete component. Like GI sheet, galvanized iron sheet, GI pipes, galvanized iron pipes. So what happens? Zinc is more reactive than iron. So which reacts first? Which is more reactive, that react first, and that will become anode. When two metals comes in the contact, how can you say that corrosion will take place? But which will corrode first? The metal which is more reactive will corrode first, because it will become anode and oxidation will take place only on anode. So corrosion will take place at anode. So more reactive metal. Zinc is more reactive than iron. Therefore, zinc coating is being done. So zinc continue to corrode, iron remains safe. Atmospheric oxygen comes in contact with zinc and form the zinc oxides. A zinc layer continue to corrode for longer durations. and iron remains safe. Because zinc will become anode and iron itself become cathode. So cathode remain protected as long as even a piece of zinc is there. Underground pipelines are being safeguarded by using the zinc pieces. We put the zinc piece after some distances. So zinc become anode and complete piece of iron pipe will become cathode. So that's why zinc is also known as sacrificial anode. We will tell you the children. By electroplating, motorcycle you are driving it, there the handle is shining. The sign, that is the nickel or chromium coating. It is covering the metal with less reactive metals. Earlier we have covered the metal with more reactive metal, that is zinc, and now I am covering the iron with less reactive metal, that is a nickel or chromium. So that is called chrome plating or nickel plating. This way also metal is being protected from corrosion. So we day to day, even the underground pipelines or ships, naval ships or the dockyards where the entire ships which are always under the water. So probability of rate of corrosion is faster under the sea, in the sea, because sea water contains the salt. As more concentration of salt, electrochemical process enhances. The flow of charge is faster in the case of sea water than normal water. Therefore, if you ask me the corrosion, where the corrosion takes place more, in normal water or sea water? Answer is the sea water, because sea water contains the salt. A salt acts as an electrolyte, sea water acts as an electrolyte. Therefore, movement of ions will be faster in sea water than in normal water. Hence, rate of corrosion will be faster. Things will get more faster corroded in the sea water than in the normal water. So I have concluded my corrosion topic. Now I will go for the rancid. Please write it.
Okay.
Okay, now let me wrap it off. I am wrapped it off. Rancidity. Children, think of what is rancidity. Okay, let's discuss it. It is your choice. Let us see. I am not advertising the aloo bhujia of the Bhikaji or Haldiram. But definitely you might be knowing the Lays, different types of canned eatables day to day you are using or purchasing in the market, which is filled with air. Sorry, we cannot afford you now, but let's think of that. What for we are discussing it. It is the best example for the rancid formation. What we do, the eatables, what we made it, what happens into that? The potato chips, the aloo chips, whatever the mixtures and different types of eatables the children used to have it. What happens? It is being taken out from the boiling oil or fats. So these eatables contains the oil and fats. These fat get oxidized in presence of oxygen. When you open this, now it comes in the exposure of oxygen and you leave it. You can experiment at home also. You can keep it 2 packets, one open and one closed. The things you will open it, after a few days it will get spoiled, it will have a smell and different taste. The taste get changed. Why? The chemical action takes place is the oil or fat present along with your eatables reacts with oxygen and get oxidized and forms rancid. Rancid causes the formation of rancid causes the change in the taste of the eatables. That's why many manufacturers, what they does it, they before packing it, they flush the packet with the nitrogen gas. The flushing of nitrogen gas causes all the oxygen to be removed, and then they put the eatables and seal it. Nitrogen gas is the least reactive. It is negligible. That's why your eatables can have the life of 6 months or a year. But definitely a small amount of oxygen remain over there and it get oxidized. Even that after more durations, after a year or so, it get oxidized, it just get changed. Therefore, to avoid the spoiling of the food, we are flushing the pack with nitrogen gas, or we are adding the antioxidant to avoid the spoilage of the taste. So this is called the process of formation of rancid is known as rancidity. Rancid is formed due to the oxidation of fats. Rancid is formed due to oxidation of fats, and this process is known as rancidity. I have concluded my chapter, that is a chemical reaction and equation. The chapter is complete. Now children, you need to do that. Here onwards, each and every question you are supposed to do that from NCERT book. Complete all question one by one. It will be done. Maximum question already covered. I have covered during the teaching process. Please, whenever you are preparing, go for my lecture number 1 to my lecture number 9. Every lecture has got the link and sequences. My lecture is complete in itself. No topic or nothing is left from the NCERT book. Please go ahead with that. Complete, revise it, do all. If at all you have a problem, post me, mail me, I will reply it. Thank you. I will wait.